Hello, this is Captain Chaudhari in my series of videos on marine astronomical navigation. We were doing the calculations on time. In last two videos, I did some calculations. We did some basics of time. In this video, I want to talk about the seasons. Not how the seasons are caused. We know from our school geography that the seasons are caused because the Earth's axis of rotation is tilted from a normal to the ecliptic by about 23.5 degrees. Sun going on northerly declination and sometimes the sun going on southerly declination. Accordingly, the climate of northern hemisphere and southern hemisphere changes. So seasons are caused basically because the changing declination of the sun. How the spring season starts, how the spring season ends. The spring season lasts, say, approximately from 21st March to 21st June, and the duration is about 92 days, 20 hours on the average. Summer lasts from 21st June to 23rd September. It takes about 93 days and 14 hours. Then autumn is 23rd September, that is equinox, to 22nd December, which is winter solstice, and it makes 89 days and 19 hours. Winters last from 22nd December to 21st March and it is of 89 days. This, we basically understand that the Earth has these four seasons. Well known, earlier introduced diagram of celestial sphere, whereby we see equinoctial and here is ecliptic. The sun travels from west to east. Now this is the position of the sun on 21st March approximately. This is called vernal equinox, right? And the declination of the sun is 0. Sun, as you know, in the annual motion on ecliptic, it travels eastwards. So from west to east as the sun goes, sun reaches here on maximum declination. This is called solstice. This is called summer solstice. This happens approximately on 21st June and the declination of the sun reaches maximum north, right? And from the time the true sun travels on ecliptic by this distance, that is by 90 degrees, that is 1/4 of the ecliptic, 21st March to approximately 21st June. This is springs. And then what happens is, after 21st June, there is a downward movement, but still eastward movement. 1/4 of the ecliptic distance is covered from 21st June to 23rd September. Once again, the declination of the sun is 0, and we say it is once again equinox. It's called autumn equinox. And this season is called summer. Thereafter, the sun still traveling southwards but eastwards reaches here, and this date is approximately 22nd December, right? The journey from here to here by 90 degrees on ecliptic is called autumn, and after 22nd December till 21st March, once again there is northward journey, and this is called winters. As far as the north-south journey in respect of change of declination is concerned, sun's declination changes from 23.5 degrees approximately south to 23.5 degrees north, right? Twice the sun is on maximum declination and twice the sun is at 0 degree declination. And as you know, when it is 0 degree declination, there is 12 hours day and 12 hours night all over the world. And when the sun is on northerly declination, right? When the sun is on northerly declination, there are longer days than 12 hours in northern hemisphere, and there are shorter days than 12 hours in southern hemisphere, and vice versa. Now let us learn as to how one can calculate the duration of a particular season. So in front of us we have the sun moving from the first point of Aries to maximum northerly declination, and this change of declination, that is from 0 degrees to 23.5 degrees. This happens between 21st March and 21st June approximately, and this is called spring's season. So let us calculate the number of days which the spring season has. Once again, let us look at this diagram, and we are interested in this part of the diagram where the true sun, which is moving on ecliptic, is precisely at 0 degrees declination, right, till it reaches maximum declination, that is about 21st June and about 23.5 degrees north, right. So these values of declinations can actually be seen from the almanac, but we are more interested in knowing as to what is the difference in the position of true sun and mean sun that time. Like I have the data taken from one of the almanacs, like we are more interested in the values, right. So this is the moment of 0 degree declination around 20th or 21st June. It happens at 6 o'clock GMT, and what I find here is at 0600 GMT, the GHA of true sun is 268 degrees and 8.3 minutes. But this GMT, if I convert into GHA mean sun, what I will be doing is 6 plus 12 multiplied by 15. That gives me 270 degrees. Because it comes from the GMT, it is GHA mean sun. And GHA mean sun minus GHA true sun is equation of time. So equation of time, when the declination of the sun is 0, when the sun is here, the equation of time is 270 minus 268 degrees 8.3. That is 1 degree 51.7 minutes. And because the mean sun is ahead, GHA mean sun is more than GHA true sun, this equation of time is positive. Now let us see what is the situation when the declination of the sun becomes maximum. What I find is there is this GMT 1800 hours at which the GHA true sun becomes 89 degrees and 34.5. But 1800 means 18 minus 12 multiplied by 15, giving me 90 degrees as GHA mean sun. And GHA mean sun minus GHA true sun, that is equation of time, once again looks like positive 25.5 minutes. 0 degrees 25.5 minutes. Equation of time is 25.5 minutes. Now what I have to do is I have to try and visualize like where is the mean sun. Like we know this side is west, this side is east. At the beginning of the springs, the equation of time was positive. That means the mean sun, if I can draw it with another color, or I will make it fully white. This is the mean sun. Mean sun is slightly to the west, right? And at the end, where the true sun is 90 degrees off from the original position on ecliptic, the mean sun is once again slightly to the west, very slightly to the west. So I would try to show it like this. This is the position of mean sun. Time wise, or the calendar date wise, the springs will last from this position to this position. This is the spring season. So what we typically do is we write down the equation of time as it is at the beginning of the season. So equation of time is 1 degrees 51.7, and that is plus 90 degrees, that is the equatorial distance from this point to this point, right? And then what we do is whatever is the equation of time at the end of the season, we negative that equation of time, and that is written over here. So I will write minus 0 degrees 25.5 minutes. So that means the distance that mean sun would travel, the mean sun would travel on equinoctial will be 90 degrees plus 1 degrees 51.7 minutes minus 0 degrees 25.5 minutes. So this will give me This will give me 91 degrees 26.2 minutes. That is the distance mean sun will travel on the equinoctial. Now what I do is, to find out the interval or duration of the spring season, what I do is 91 degrees 26.2, I multiply this with 365.25 and divide it by 360 degrees. I get 92.77. I get 92.77 days. This means 92 days and 18.5 hours. So this is the duration of the springs, right?